Ice helps regulate our climate system. There's sea ice, which is frozen water that forms, expands, and melts in the ocean. And there's also glaciers, ice sheets, ice shelves, and icebergs that originate on land. But as the planet becomes warmer, the Arctic keeps losing ice. So what happens if the Arctic ice continues to melt? In the winter, frozen seawater covers most of the Arctic region, but its extent changes based on seasonal temperatures, thinning and shrinking during the spring and summer, but thickening and expanding during the fall and winter. With warmer temperatures, the ice albedo feedback loop kicks in. Warmer temperatures melt the sea ice earlier in the spring season, which leads to more ice loss, ultimately resulting in a fragile, thinner ice layer. The thinner the sea ice becomes, the more fragile and likely it is to melt, transforming bright, reflective ocean surfaces into dark, open ocean waters that absorb more heat. This feedback loop can move the climate system towards tipping points where further ice loss may be unstoppable. Melted sea ice wouldn't contribute to sea level rise because it's in the water, and therefore, its volume is already accounted for in current sea levels. But the warmer temperatures would also cause the ice sheets to destabilize as pieces start to melt into the ocean. And since ice sheets are on land, the melted ice that streams into the ocean would be an additional amount of water that is not accounted for in current sea levels. For example, if the Greenland ice sheet completely melts, sea levels are estimated to be 6 meters or 20 feet higher. That would be the equivalent to the height of a 2-story house in the United States. And if the Antarctica ice sheet melts, sea levels would be 60 meters or 200 feet higher, which is equivalent to how tall the Colosseum is, plus an additional 43 feet. The water in ice sheets and glaciers holds most of the fresh water on Earth, about 68%, a significant amount that could change the seawater salt content as it melts and streams into the ocean, which in turn would affect the ocean circulation patterns responsible for transporting heat around the world. The next video highlights the role of ocean currents in the climate system and what would happen if they stop working.